Good morning, everyone. Today, I want to talk about the growth, mortality, and recruitment signals in H0 gadids settling in coastal Gulf of Alaska. First, I want to introduce the gadid. The gadid we often call as the gadid cod, and they live in a water temperature 2 to 11 Celsius degree. And over 1/4 of the marine fish harvesting of the world. It means the gadiid is an economic species. But unfortunately, in 1980, the northern cod decreased 82%, so it almost extinction. So it's very important to protect the gadiid. Then I want to talk about how gadids breed. First, the adult gadid will breed in spring. And the age 0 to 1 gadid will live in the coastal Gulf, and the water depth is 2 to 4 meters. And when they get older, they will move to the deeper water. But we can observe whether the juvenile gadid or the adult gadid, they will move back to the coastal Gulf in July and August. So the purpose is 3 different juvenile gadids have the same pattern of their recruitment in age 0. And can age 0 gadids predict the gadid's future abundance? Here's the sampling station. It's located in South Alaska, Kodiak Island, and we choose 2 different bays. One is Anton Larsen Bay, ALB, and the other is Cooks Bay, CB. And we pick up 8 stations for each bay. And the time is from July 11 to 21 and August 21 to 29 between 2006 and 2013. Then how we do the experiment. The first tool we use is a demersal beach seine. We will deploy the seine in the water depth 2 to 4 meters and set parallel to shore in a 25-meter distance. And this is how it works. The fish will get into the seine. And we only choose the juvenile gadids for our experiment. And the second tool we use is the baited camera. We will deploy the camera in the water depths, 6 different depths. And each depth will experiment for 50 minutes. And the distance between each sampling station will more than 100 meters because we want to avoid the attraction of fish from the previous sampling station, because in the red circle one is the baited bag. It contains a sardine, and this is how it works. The blue circle is the camera. So when a fish eat the sardine, we will take a picture for the fish. And our target is the older gadids, 1 to 2 years old. And after we have the experiment, we will analyze the data. This is a DJ value, and the DJ value is lower. It means the nursery region, ALB and CB, have a similar pattern in H0 recruitment across years. This is what we like to see. And next is the result. And the axis is the month, and the y-axis is the temperature. So we can see in July and August, the temperature variation is stable. So it tells us the temperature won't impact the experiment data. Then this table, we can see the Pacific cod is dominated the relative abundance. And the walleye pollock, it has a huge difference in the interannual variation in abundance. Like this one, ALB is 0.91 and CB is 1.669. And in this figure, the x-axis is H0 Pacific cod CPUE, and the y-axis is the H0 walleye pollock CPUE, and the H0 saffron cod CPUE. What CPUE means is the catch per unit of effort. This indicates the species abundance, and this is the linear regression. The solid line is the ALB, and the dashed line is CB. So in the upper one, we can see the Pacific cod and the saffron cod have a positive relationship of abundance in ALB and CB, Anton Bay and Cook's Bay. But the down one, we can see the Pacific cod and the walleye pollock only have the positive relationship in ALB. And in this figure, we can see the DJ value. The walleye pollock have the higher DJ value. It means the H0 walleye pollock's recruitment change every year. But after all the gadids p-value, it's 0.028. It's smaller than the 0.05. And it means this data is reliable in statistics. So ALB and CB abundance every year still similarity. Expect the walleye pollock. In the beta camera result, because we don't have observed any walleye pollock in a beta camera, so we will miss it. And in this figure, the x-axis is the H0 CPUE, and the y-axis is the H1 CPUE. So it's compare the H0 and the H1 abundance. And in this figure, we can see they only have the positive relationship in the Anton Bay. So it might be the Anton Bay water depth is higher, so it may be have the higher growth potential for the Pacific cod and the saffron cod. And in this figure, x-axis is the H0 CPUE, and the y-axis is the H2 CPUE. And we can see in this figure, only the saffron cod can compare the H2 CPUE. So it means only the H0 saffron cod can predict the H2 saffron cod abundance. Here's my conclusion. In H0 Pacific cod and the saffron cod have the same pattern of recruitment in ALB and CB. But the nursery area ALB and CB is less vital for walleye pollock because we don't observe any one H1 or H2 walleye pollock in the beta camera. And the H0 Pacific cod and saffron cod can predict their H1 abundance in ALB. And the H0 saffron cod can predict its H2 abundance. Here's my presentation. Thank you.
First, thank your presentation. I think you have like modified most of the improvement you need to do that's mentioned by the teacher. Like you had to enlarge your fonts and you remove the unnecessary space. You also remade the table and condense the information. I think it's quite good.
Thank you for your presentation, and I'm gonna call you a master of animation because you use the animation to demonstrate how the fish being catched, and it is really good for the audience to understand how it works.